Our final speaker for this plenary session is Deborah Walker. Deborah is a senior research engineer with the US Federal Highway Administration. Specialising in highway research, she manages the traffic data collection and communication activities for the Long-Term Pavement Performance Program. She oversees the technical and administrative duties for collecting quality traffic data from across 2,000 pavement test sections located throughout North America. She also leads and directs the publication of LTPP outreach material for the states and industry partners. Deborah is also a member of the International Society for Way in Motion and serves on the Executive Board of Directors as its General Secretary. She's also a member of the Transportation Research Board, TRB, Highway Traffic Monitoring Committee, and co-chair of the TRB Way in Motion Subcommittee. Deborah.
Good morning. And it's a pleasure for me to be here. Thank you, Gavin and Chris, for the invitation to come and speak as part of the panel. I feel like this is sticking right in my face here. I just want to say that when Chris asked me to, who could speak on behalf of North America and experience with heavy mass, I jokingly said, well, maybe I can get the Secretary of Transportation to come. Our Secretary of Transportation is Pete Buttigieg, and just wanted to show you here. So this is Pete Buttigieg. I could not get him to come, but I did meet him in person on October the 30th, and the picture that I'm showing here is he was out at the Turner Fairbank Highway Research Center, which is the research arm of the Federal Highway Administration where I work. And he was there to do a ribbon cutting for our new pavement testing facility. So behind us there, you see the blue machine. So that's one of the machines that's there. We have over 10 test lanes that's been instrumented with lots of sensors. And so we'll start data collection and looking at different types of pavement structures over the next couple of years. And the reason why I wanted to bring this up is because the old testing facility that we had, the automated facility load system, the ALF, was disassembled at Turner Fairbank and shipped here to Australia. So it's somewhere here. I don't know exactly where it is in the country. Maybe somebody in the audience knows. But the old system is back here, and we have a new one now. So I wanted to show this picture just to let you know what's going on and what's in the background there. And one of the things that the Secretary talked about was the work that's being done at Federal Highway, the research center there. And he did mention that many times within infrastructure, we don't get the attention from the media about what we do, but the work that we do is very important, and he recognized that. And that was something that we all appreciated. Before I get into my talk, just wanted to tell you that he's a very nice guy. The picture on the left, me shaking his hand, we were talking because I met him virtually about 3 years ago. There was, in the US, we have something that's called Take Your Child to Work Day. It started off as Take Your Daughter to Work Day, so that daughters could come into the workplace and see their parents work. But then many people wanted to include the sons, and so it was changed to Take Your Child to Work Day. Well, in 2020, we didn't have it because we were all in pandemic, but in 2021, there was a Take Your Child to Work Day, but it was a virtual event. And they had contacted different people within the Department of Transportation to ask if anybody would like to bring their child to interview Pete Buttigieg. Well, at the time, my youngest daughter, was a senior in high school, getting ready to go to college to study journalism. And I said, well, would you like to do this to interview Secretary Pete? And she said, oh, yeah, go ahead. So I submitted her name. She was selected. And so that picture on the left with me shaking his hand is a reminder of the time that he and I met virtually, and he couldn't believe that she's getting ready to graduate from university pretty soon here. And so then the other picture is just a picture that he took with all of us after the ribbon cutting. So just kind of wanted to give you that. I know we're seeing a lot of PowerPoints this week, so just so that you know, this is my PowerPoint presentation. So just wanted to leave that up there for you. But I want to go ahead and just give you a little bit of how North America uses heavy mass. In putting this together, I worked with several people to give some talking points, just to give a big picture of what we do. Hi, everybody over there. I know you probably can't see me from the monitor, but, and I wanted to point out a couple of people who worked with me to put these talking points together. Yesterday, Chris talked about the human factor. There are many good people that I work with at Turner Fairbank, at Federal Highway Administration, in collecting traffic data and collecting pavement performance data at our test sections. And so I wanted to recognize those people who helped put this together. Stephen Jesberger is one person in the office here. He works at Federal Highway in our Office of Policy and Information. Olga Someznova, some of you may have worked with her too. She's one of our contractors at Federal Highway, working with me on traffic data collection activities and doing different traffic data analysis projects. She works for Applied Research Associates. And also Roy Zinku, who works for IRD. He's one of our contractors who has installed and continues to maintain and collect the data for the weigh and motion sites that we have at the LTPP test sections. So with the three of them and myself, we put these talking points together. You don't have any slides. I don't have to worry about doing any click or anything like that. But we just wanted to give you a big picture of how heavy mass is handled in the U.S. So my talk is going to be broken up into 3 different sections. I'll answer the question on how North America measures heavy mass, how we use the mass and who uses it, and what are some of the innovations in collecting and using the heavy mass in the US. So how North America measures heavy mass. North America, and specifically the United States, measures heavy mass, which is typically referred to in the US as truck weight and axle loads using static and dynamic methods. For the static methods, the US uses portable and permanent weigh scales. Permanent scales are typically installed at weigh stations located at strategic locations along the major highway and at the port of entry points for many states, usually by the state's borders, as well as port facilities and other heavy cargo terminals. The purpose is to determine the truck weight or the heavy mass and axle loads to make sure trucks are compliant and weight regulations for the federal and state and is properly taxed to use on certain roads. Like the permanent static scales, portable scales are deployed by enforcement agencies at different points on the road, on the side of the road. Now, in terms of dynamic roads, for dynamic methods, in North America, we use primarily weigh motion technology with sensors installed in the pavement. Most frequently used sensors are piezo quartz, bending plate, strip sensors, and piezo polymer. There are around 600 permanent weigh and motion sites installed in the US. Portable WIM is used, but its application is limited due to the accuracy and the challenges in calibration. Bridge WIM technology is being tested for routine applications by several states, but as of yet, it has not received wide acceptance. So we still have some work to do in terms of the bridge WIM. Now, the next question I want to answer is how heavy mass data are being used and by whom? Truck weight and axle loading data are being used by the government at the federal and state levels, as well as by researchers, practitioners involved in transportation infrastructure design, monitoring, and analysis. At the federal level, heavy mass data are being used by the Federal Highway Administration to support the following: emissions and noise studies as part of the National Database Air Quality for Noise Analysis tool, which stands for the DANA tool. the National Freight Analysis Framework to help calibrate the model, used along with the Highway Performance Monitoring System, or HPMS, for single unit and combination unit annual average daily truck traffic. It's also being supported by Federal Highway by the use of the National Highway Cost Allocation Model, the Long-Term Payment Performance Program, which is near and dear to my heart, the Long-Term Bridge Performance Program, various federal, state, and academic research studies to advance highway, pavement, bridge design, operation, safety, and management. FHWA's LTPP InfoPave, I'm going to pause here for a minute, just by show of hand, how many of you have heard of the LTPP InfoPave web portal? Okay. You don't count, Stephen. How many of you use it? I know you use it. Okay. I would encourage you, if you haven't looked at it before, take a look at it. There's a wealth of information there, both in terms of pavement performance and also traffic data. We also have a very good climate tool called the Mirror Data, which we've gotten data from NASA. So there's a lot of good information there. So just a commercial for InfoPave. But the portal has information about truck weights at over 2,000 monitored sites that are monitored by the LTPP program. In addition, Federal Highways Office of Policy Information has a new dashboard for displaying truck weight data across the U.S. and will soon add the overweight truck reports to the dashboard. FHWA has a national map of the 521 sites in its Travel Monitoring Analysis System, or TMAS, and some of you may have heard that term before as well. And both the data from InfoPave and TMAS are available free of charge. So you're getting quality data at no cost to you. FHWA is working on action plans with numerous state agencies to collect WIM data from all 52 states, plus the District of Columbia and Puerto Rico. Now, at the state level, truck weight and axle loading data collected by WIM systems are being used by the state highway agencies primarily for pavement design and for reporting WIM data to federal programs. Accurate measurement of truck weight and axle loading data is of the highest importance for pavement design, analysis, and forensic studies. This importance has been long recognized and reflected in traditional pavement design methods with equivalent single axle loads formulation that escalates the importance of heavy axle loads by a factor of 4. Accurate measurement of axle loads is also very important to new mechanism empirical pavement design methods, the MEPD, known as the MEPDG, and those models show that overloaded vehicles are key contributors to pavement distress development, such as cracking and pavement failure, which I'm sure is not a surprise to you. Heavy axle loads are reported by WIM system for individual vehicles and FHWA vehicle classes 4 through 13, starting with 2-axle and 6-wheel trucks and up, and each axle load application. These loads are used to create load spectra that are used to compute ESO or used directly in the pavement design. Axle load spectrum is a statistically frequency distribution showing the number or percentage of axle load application at each load level. And it's been by 1,000 for single axles, 2,000 for tandem, and 3,000 for all of the axle types. States also collect truck weight data at static weight scales for several purposes. Number one, to enforce compliance and safety regulations by checking freight carrier compliance with fuel tax laws, federal weight limit, elected gross weight, weight restrictions, and equipment safety. And number 2, to collect taxes on transported goods based on the weight. These functions are regulated by individual state governments and differ from state to state. So depending on what state you're in, you have to get a permit to carry the overloaded weight for that particular state. And they are typically operated by the state departments of transportation or the Department of Motor Vehicles in conjunction with the State Highway Patrol or state police. So that's how heavy mass are being collected and by whom from the federal and state level. And then lastly, I would like to talk about the innovations in collecting and using heavy mass data. With today's technological advances, WIM is being used in many new and innovative ways. The industry, federal and state data owners are demanding the ability to deploy one system that will meet the needs of multiple agencies and user groups. In other words, doing more with less. Collecting the data once and using it multiple times. Advancements in WIM electronics and data processing can allow this to occur seamlessly. Super WIM sites that integrate a multitude of sensors collecting truck weight, axle load, visual truck information, and infrastructure for both pavement and bridge. Response data are being tested throughout the U.S. In addition, strategic selection of WIM location allows heavy mass data to be collected and used for enforcement, pavement design, planning, management, and protection. By placing WIM systems near state lines or along the major freight corridors, WIM data can be shared between multiple state agencies. And with that, this concludes my remarks on how North America is using heavy mass. Thank you for your time.